Welcome to part 3 of lecture 11. In this part, I just want to give you two examples of how you find the standard matrix, find the matrix of a linear map with respect to some bases. So I'm going to start with an example that's actually very similar to what you would have done in Math 1B03. So I have a linear map going from R3 to R2, and it's given by this information. I take the triple x, y, z, and the first coordinate of it is going to be x plus 2y plus 3z, and the second coordinate is just going to be 4x plus 5z. Now you probably actually have enough information from Math 1B03 to answer this, but I want to kind of show you how we're going to answer it using kind of what we described in the last part. So we need a basis for R3 and we need a basis for R2, and I'm just going to use the standard bases for both of them. And even though I wrote E prime and E2 prime, this one just means the vector 1, 0, and this means the vector 0, 1, and so on. So now the first thing that we need to do is take all of our standard bases of R3 and stick them into our function and find out where they go. So I take T and my map T, and I plug in 1, 0, 0. So I plug it into this formula, so I get 1, 4. And then, what I want to do is write 1, 4 in terms of the basis for R2. And the way that I do that, right, is 1 times the vector 1, 0 plus 4 times the vector 0, 1. So you can think of this as 1 times the first basis vector plus 4 times the second basis vector of R2. Now we do this for each of the basis elements of R3. So 0, 1, 0 gets sent to 2, 0, which you can convince yourself is equal to 2e1 prime plus 0 e2 prime. And then t0, 0, 1 gets sent to 3, 5, right? And you can think of this as 3 times 1, 0 plus 5 times 0, 1, which is equal to 3e1 prime plus 5 times e2 prime. And well, we can use this information to build my matrix, right? Because here's MT. And normally you don't have to put this information here, but we'll do it now just to kind of keep track of what we're doing. So E1 gets sent to this linear combination of E1 prime and E2 prime. So those tell me what my first column looks like. The 2 and the 0 tell me what goes into the second column, and the 3 and the 5 tell me what go into the last column. So this is the matrix of the linear map with respect to these bases. Okay, so that's an interesting example, but let's do something a little bit more complicated where we can use some calculus. Okay. So here I'm looking at the vector space of all polynomials of degree 3 or less, and I'm mapping from that set to the set of all polynomials of degree 2 or less, and I'm using the differential map. So the differential map is you just take the derivative. So you take a polynomial of degree 3 and you map it to a1 plus 2a2x plus 3a3x squared. So I just take a polynomial and I take its derivative and I get something of degree 2. Now, both of these vector spaces have bases, right? So the basis for P3R is 1x, x squared, and x cubed. And the basis for P2R is 1x, x squared. So what I need to do is take each of these basis elements here and take the derivative and then write it in terms of the second basis. Right, so let's do the calculus part first. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x. And the derivative of x cubed is 3x squared. Right, so that's just some basic first year linear algebra. But now we want to write it in terms of my basis. So 0, we can write it as 0 times 1 plus 0 times x plus 0 times x squared. 1, we can write as 1 times 1 plus 0 times x plus 0 times x squared. 2x can be written as 0 times 1, 2 times x plus 0 times x squared. And 3x squared can be written as 3 times 1 plus 0 times x plus 3 times x squared. I'll make my 3 a little nicer. And so this information here is going to tell me what my matrix looks like. And so I have room on the next slide to do that. So I'm trying to make my matrix MD. And since it's still early days, we're getting used to this. Let's write down our basis elements that we're starting from. And over here, we can write the basis elements to where you're going. And in these columns are going to go the coefficients that we found down here. Okay, so it's a little hard to have both slides up at the same time, but I'll just write them down for you quickly. So 1 gets sent to 0, which we can write like this, 0, 0, 0. X gets sent to 1, 0, 0. X squared gets sent to 0, 2, 0. And x cubed gets sent to 0, 0, 3. So this map right here is the map of the linear map D with respect to this basis, and this basis for the first vector space, and this basis with respect to the second vector space. So hopefully these two examples help, and now we'll kind of talk a little bit more about these matrices in the next part.